Hi everyone. Really excited to be here and see so many faces, eager to learn. The eyes are open. You're very excited to hear about the session to build, launch, and scale your Web3 startup on AWS. And we want to share some aggregate learning that we've collected over the last few years. But you're not only going to hear from me, we have this exciting opportunity to hear from an actual customer, 1inch, and about their journey onto AWS. So before we start and dive into all the exciting topics, I want to get to know the audience a little bit better, just to understand who are we actually talking here with. So by show of hands, who of you is currently in an idea or concept stage of maybe a Web3 startup, some kind of product or service? Anyone right now ideating? I see some hands up there in the back, okay. So are some other people currently building? So you maybe are some looking for product market fit, you're doing some MVPing. Anyone building? Some more hands on there. That's fine. We have content for both of these groups here today. And now a general question that I always like to ask with my customers is, who of you thinks that you in general think more about managing infrastructure than focusing on building a next generation product? I see more hands. That's fine. I totally understand that. As a former startup founder myself, I know how it is that you have to make a lot of trade-offs every day. But this is exactly why we're here today. We want to show you some of those aggregated learnings. I want to actually walk you, that when you walk away, that you've learned something, but you also know where you can continue learning in this exciting space. So on those slides, you will find a lot of QR codes and URLs for further links, which then all will go into details onto the things that we talk about today. My name is Tim, and I'm a startup solutions architect with AWS for a couple of years already here. And I work with fintechs and Web3, decentralized finance startups, and my mission is to help them build a scalable and cost-effective architectures on AWS. So how we're going to do this today is, we want to understand how AWS and Web3 comes together, and actually what have we done already in this space for the last couple of years. And then we're going to zoom in and hear from 1inch, from Sergej Kunz himself, about their journey and how we actually built together their new setup, alleviated some of the pain from the developers, and improved the customer experience. And then in the second half, I'm going to zoom out a little bit, and we look at general patterns that we see that keep emerging when we talk with our customers. So you might be asking, why AWS and what are you doing in Web3? Well, the reality is we've been working in this space with exciting players for a couple of years already, and we help them enable and build those products that you might be using every day. And I know that for sure because I recognize a few faces whose products I'm using. So this is a very exciting journey that we've went over the last couple of years. And AWS supports startups and companies of all types and sizes. Here you can see a few of those examples, and by the way, I would love to see everyone's logos on this slide here at some point, so come talk to me afterwards. But so when you think about the general ecosystem that we're supporting, it starts with the global exchanges. So some of the biggest global crypto exchanges are using AWS to run their services. So the centralized finance space, but also the decentralized finance space, where we're actually going to hear so much more later from 1inch. Where you hear it from straight up from them themselves. But it's not only the centralized exchanges, decentralized layers, but also the actual infrastructures. So in the Web3 space, you talk about layer 1s, layer 2s. So these people that actually build the underlying infrastructure that all of those products are using. And as an example, we have a partnership with Ava Labs, and these are the people that built this popular blockchain Avalanche. Make it easy for you if you want to build a decentralized application on their subgraphs. You can just go onto the AWS Marketplace, and with one click deploy all the resources that are needed, and you can go and start building. So these are the kind of things that we can do and help and accelerate your journey into this field. And then you see also a couple of other names there. So this is around DevOps and tooling and some other tooling, like, for example, understanding what is actually going on the blockchain. For example, Chainalysis that makes it easy for you to actually shoot queries against what is actually happening on the blockchain, and you derive some analytics. And some other players that are not natively crypto native, but are actively moving in that space, be it fintechs, be it social media. So what happens when we wrap this all up? What is actually the mission of AWS in blockchain and in Web3? We at AWS, we want to empower you, these are the builders, the people with the great ideas, to build the next generation of the internet. And by way of doing this, providing first-class security, reliability of the services, help removing undifferentiated heavy lifting, help with go-to-market, partner strategies, all the things you might be already aware of, we're also doing in this space. But I want you not only to hear it from me, we actually have one of these examples here today. So it's my pleasure to introduce Sergej Kunz, the co-founder of 1inch, who's going to walk through their journey, 1inch's journey onto AWS.
Thanks.
And the clicker.
So hi everyone, you can hear me well? Right, okay. So hi everyone once again. My name is Sergej Kunz, software engineer, software architect for 18 years and co-founder of 1inch Network. And I'm going to tell you our customer journey here together with AWS. We are very thankful to AWS who support us always, every time when we need them. So what is 1inch Network? 1inch Network seamlessly unites decentralized protocols, empowering users to perform efficient, user-friendly, and secure operations within the Web3 space. So it sounds very complicated. It is indeed. We have built over 3 years a lot of services. We became in just 2 years unicorn. We raised our last round around 175 million of US dollars at more than 2 billion of US dollars valuation. We started with the aggregation protocol, which is very complex, use very complex algorithm, and together with our client, we call it client, the app, which is just a front-end application based on Angular, which offer really great user experience. We have built our own self-custody cryptocurrency wallet, which you can use to own. So the Web3 is about to own. Like Web2 is about like sharing, like social networks and everything. But Web3, to understand for everyone, is like you own your assets. And we are working also on hardware wallet, like Ledger. We have our DAO. We have decentralized autonomous organization, which contains a lot of contributors, and of course we have our token launched by 1inch Foundation back in 2020. We have a lot of protocols, limit order protocols like decentralized order book protocol, and we are building institutional service for institutional players, banks, to offer the same high quality, high security standards of decentralized finances for traditional finances. So our performance, we started back in 2019 on the hackathon. It's like competition for programmers. Over 2 sleepless nights, we have built the first prototype, which offered the best execution among decentralized exchanges. We built an algorithm which distribute your swap amount between multiple liquidity sources to achieve the best rate. So in the real world, you would use to buy Tesla stock, for example, for 200 million US dollars, not just on one exchange, right? You will not go to Stuttgart exchange and exchange everywhere there because there's a lack of liquidity. You would split it in small amounts and exchange everywhere a little bit, and maybe also using different fiat currencies like Euro, Swiss franc, and so on. So this is what we actually solved with our product. We keep still 70% of market share of the aggregation of the swap product. We invented the aggregation in Web3 space. We have 4.5 million of users. We are still small in the space. We're really small in the Web3 space compared to the traditional finances. But these people generating more than 300 billion of US dollars since 2019. And I already said we raised around 190 million in 3 financial rounds. And we deal with 1 billion requests a day on our APIs. So here we go, how we use AWS. Almost everywhere we try to use services which are fully managed, like fully managed Kubernetes service. It's used in every team who build microservices. Web3 is not just about smart contracts and blockchain. It's kind of very limited. You need sometimes aggregated information, and it needs to be stored somewhere, and it needs to be served from servers. Yeah. So we use to scale our and to upscale and to downscale our Kubernetes. We're using Carpenter, and we have 1 billion requests a day. And we have only 4 DevOps people who are dealing with this, because without AWS we couldn't grow and scale like we do it right now, because they offer really nice service, which is most of the time fully managed. I'm going to go through our products and we'll tell you what is under the hood and what runs on AWS. This is one of our important things. This is our algorithm. This is min cost max flow algorithm, which needs a huge amount of CPU resources. We have 350 servers on which we run our algorithm, and we generate the response in 10 milliseconds. And that's why we are using Graviton. So Graviton, compared to the Intel CPUs with 64 virtual cores, provide better performance, much better performance, so we can reduce our server amount and pods amount to deliver the same responses, yeah, but with lower latency and lower costs. Another product is our 1-inch self-custody wallet. Yeah, in a wallet, like also in your bank account, you would like to see the history, right? But the history is not coming somewhere. It needs to be kind of prepared, generated. The data needs to be aggregated. The blockchain needs to be indexed. Yeah, and to provide such a nice service where you can see when you did what, transfer, swap, or you staked, or you got an airdrop, you need to get the notification. For these services, you need microservices, which are built on top of AWS. So here, the history service is actually built on another microservice, which is just taking care about indexing the blockchain. So on each block, to really understand what's happening in the history of the wallet, you need to index and trace the block, like really understand what's happening inside of the block in the transactions, which states changed. To do that, like to understand what's happening in the block, we have an indexer, which uses the Amazon managed blockchain nodes, which is also really helpful because there are a lot of services who offer like Ethereum nodes, which you can use to perform the Web3 calls, like give me the balance of the wallet, for example. Yeah, but most of them are not really stable, I would say, and costs also a lot, and we don't have it under our control. Sometimes it's happening, they just die. Yeah, so that's why Amazon managed blockchain nodes are really, really good. So we have under our control. We can upscale, we can downscale, and it's fully managed. So we don't care about if a fork happens, kind of there's some troubles in the network itself because someone is attacking it. Reorganization happens automatically here. We don't have to deal it by ourselves. And we use a queue system to just get the events, the new blocks. We store them in S3 bucket. It's also really nice service. You can just store like data and can access from different multiple services in parallel with high performance. You don't care about, I don't know, like how it's stored, where is it stored. It's fully managed and works very well. And you can use some triggers. You can add some events and react on multiple microservices on that. So, and on top of this information, we have built another microservice which uses the blocks, listening on each event, like on each block. Every block on Ethereum happens every 12 seconds. So on each event, we need to parse the block, we need to aggregate the information, we need to store it and also fully managed database. It's also pain if you run it by yourself. You need to run a cluster, you need to manage the cluster. I don't care now. So we don't care now because Amazon is doing it for us. So, and of course, microservices running on Kubernetes, aggregating here information storing in AWS, RDS, fully managed database, and we use our OneH API to serve this request to the user. Yeah, just only few examples. Almost everything we have built based on microservices, based on Kubernetes, based on like fully managed databases, no index databases as well. So we are using also Rabbit, fully managed RabbitMQ. There's a lot of nice products from AWS which save you time and money. And I already said we would not be able to grow and scale without AWS. So thank you very much.
Thank you, Sergej. Great. Sergej, thank you so much for your time and the unique view into the fascinating world of decentralized finance. There's a lot of things that flew around, but I hope you got the idea of that. There's a lot of things we can do together, and we can re-innovate the things, like how you do them. Like the last slide he just presented, it came from a POC that we ideated together, and now they're using this in production, and it's really great to see like how we can re-innovate together. So now, I promised that we saw now those pinpointed examples of how OneInch was helped by AWS, but I wanted to zoom out and look at broader patterns. I am in the great position that I speak to a lot of exciting customers in this field, and we all learn together. And there's two main topics that kept re-emerging. So those patterns emerged and those questions that kept being asked again. One is, how do I actually get started? What are different options for me to run the required infrastructure? How do I actually read the data from the networks? And then as a next step, how do I actually make sense of them? Because if you may have looked into, maybe run some nodes on your own and you looked at the data that is being processed there, not all of them are very human readable. So that is the first part. But the second part is, maybe I have all of this set up, but how do I actually participate in the network? There's some private keys that you need, so sensitive material that needs to be stored somewhere. What are different approaches how to do this? And this is exactly what I want to go over and share some of those learnings that we had over the last couple of years. Now, as I said in the beginning, I want you to learn something. Here, you spent donating your time for this session, but I also want you to know how to continue. So please, check out the QR codes and the URLs that are provided here on the slides. If you want to have the slides afterwards, please come to me, and I'm happy to share with them with you. Now, before we start, let's take just a short moment, because I realize maybe we're not all on the same speed here, just to realize what we are actually trying to achieve. So you might be thinking about your application. You maybe have already some code, some sample applications that's being run via databases that power your service. But there's this whole other world of the blockchain. It's the smart contracts, maybe these are part of your application logic. And we have all of this valuable data that is being stored on what we call on-chain, so on the blockchain. So how do we bring those two things together? And that is being done by a piece of software that's called the blockchain client. It's typically open source. We can download it. We can put it on a machine and get it up and running. But why is this important? It's important because this is your gateway into the whole blockchain space. So also, that's why we should start looking into this specific case first. So let's talk about this read case. So you want to have the required infrastructure to actually get information from the blockchain space. And you see here a sample architecture that I drew. And we're not going to focus on the left side. This is our application. We have our front end running, but we want to focus on the right side, this box here, where I put in different options on how you could do this. Let's start at the bottom. So in reality, there's a lot of options out there. There's some startups that made it their model to offer you managed nodes. These are a lot of the typical names that are flying around, be it Infura, Alchemy, SQL Node, and all of these. But when I talk to customers, I typically see them using 2, 3 of those providers just by way of their availability requirements, or because each of those startups, they might have a different focus on networks, and in order to get the whole network coverage that you envision, you might need to use several of those players. But as I said before, the blockchain client, so that piece of software that actually allows you to get the data from the network, to interact with this, is usually open source. So you can go to a GitHub repo, you can go to the web page and download the client and put it onto a virtual machine. Could be a virtual machine in EC2, you download the software and you are all ready to get started. What I increasingly see though is the need to manage that scaling, this orchestration of those nodes, because maybe you're not connecting only with one network, maybe with many different networks, maybe you have then different nodes that you need to take care of. So what I've seen increasingly customers using is Kubernetes to actually do the scaling, and maybe they're even using Amazon EKS, so the managed Kubernetes experience in this case. We saw an example also earlier from 1inch that they're also making use of Kubernetes to power their microservices and their node infrastructure. So there's one caveat. Maybe some of you who already tried it out, or like me, 2-3 weeks ago, I'm working on some content right now, so I spun up a node and I installed all of the required clients to actually get up and started. And then there's this process of syncing happening. Because if you don't have a prior snapshot of the blockchain, and you just start from zero, you will need to download, depending on the full or maybe some truncated version, but you need to download the state of the blockchain. And that can take some time. For me, in my Ethereum client, I had everything up and running on my virtual machine. It took me over 24 hours to actually get fully up and synced. That has nothing to do with AWS, it's more about how the software and this peer-to-peer network works. And I would argue this is maybe not always the best case to scale. There's some ways how we can circumvent that, and if you're interested, please come to me afterwards and we can discuss this. We built some great models with customers. But there's also another way that makes it easier for you to get up and running much more quickly. And that is the third box on top, the Amazon Managed Blockchain. So let's just take a short moment to double click on this and how this can be helpful for you. So Amazon Managed Blockchain, or in short AMB, is a fully managed service that actually makes it easy for you to create and manage blockchain node infrastructure. In the public blockchain case, it supports Ethereum. So what you will get is a fully loaded, fully synced Geth full node. And then makes it very easy with just a few clicks to create this node and get up and running in minutes rather than in hours, or in my case, it took me more than 1 day to actually get fully synced and run. So the nice thing is you can also experiment more. If you just want to get a feel about how it is to connect to the main net, to connect to the test nets, and you don't want to manage all of this infrastructure on your own, you could use AMB because it's fully managed for you. And then, if you just want to MVP a little bit and play around, you can use the provided Ethereum APIs, the APIs that are provided by Amazon Managed Blockchain, connect it with your front end and get ready and started, and connect to smart contracts in the back end, read data, and all of the things that are required to power your product. Here at the bottom, you'll see a link to an infrastructure as code template to actually get this spun up very quickly. If you don't want to go into the AWS console and click around, but actually want to work with code, I would understand. I'm doing the same. This is built in CDK, so the AWS Cloud Development Kit. If you prefer Terraform, come talk to me afterwards. I'm actually publishing a module just next week to make it easier for you also get started up in Terraform. So we looked at this case of the required infrastructure to actually connect to the network. And we're able to pull data and make sense of it. But how do we actually interact with this? So not only reading, but also writing to the network, let's say, or signing transactions. In the case of Ethereum, because most people know this, so let's take this as an example, you would have an Ethereum account. And what this means is you have your public key, which you can use to derive your public address. But you also have the secret key, and this is the even more important part, the one that you should safeguard, because this allows you to sign sensitive operations. So you should really safeguard those credentials. Now, in fully decentralized applications, these are the topics that we talk about in Web3, we would usually expect the users to hold their own keys, maybe in their own wallets. But sometimes it can make sense to have key material live closer to the actual application. For example, when it has to be accessed very frequently, when you want to do some automated operations, or when you want to delegate some of the operations to this provider. Some of those examples, just to give you an example, could be delegated staking, could be NFT minting, or frequent withdrawal and deposit actions on an exchange, for example. So we see here the small change at the bottom, where I put in one more logo. And this is the AWS Key Management Service, or in short, KMS. And think about it as a managed experience for hardware security modules. Those modules, they are hardened for those people who are taking notes. These are FIPS 140-2 validated for those people who like to go into the details there. But those modules make it easy to create and store safely credentials and important information like those secret keys. Now, the nice thing about this is you don't need to be an expert in hardware security modules, and I wager that most of us aren't. But you maybe want to use these for their security requirement. So KMS makes it easy for you because it's fully managed for you. You don't need to run any of the infrastructure required, any of those modules. You don't need to think about scaling. You don't need to think about how many keys can I put on a cluster. All of these questions you don't need to think about. You just store your secrets, and you're paying for those secrets that you're storing and the API calls that you're making. So it's just pay as you go. So that really can make your life much easier. There are more advanced versions of doing this key management. Again, if you want to go into those details, I'll be available after the presentation over there, where the letters are lighting up there, and we can go into more details. So we looked at this case right now where we had the key material that we needed, the sensitive key material that we need to sign, then those transactions that we want to safeguard, and we had them live close to the application because of the things that I just mentioned before. But in fully decentralized application, we would actually have those key material living with you, the users. So you might be holding this in your own wallets, or maybe you have your own notes where the key material is living. So in this case, we have our application, but it needs to be signed by the user. So it will be signed by the wallet, and then we will wait until this transaction is finalized on the network, so we can actually pick it up here with our blockchain node. I put Amazon blockchain here again, but use it as a placeholder for anything that works great for you. We went over those examples just earlier. And then we can make make sense of the information that comes in. Mentioned earlier, if you look into the event data, the kind of things that you can pull from the blockchain, there's a lot of alphanumeric strings and hashes that are, maybe you're superhuman, I cannot read those, so I need to make sense of them. I need to match them with information that we already have. Maybe about these are the specific wallets of your users that you want to then actually list out all the transactions that they make, so you can display it in your own application. So all those kind of things you can enrich in this step here and make sense of the information that comes from a blockchain, and then we can keep on going in our application. So these are the two cases where we interact with the network, but it's a very fundamental difference of where this important key material lives that allows us to sign off those operations. Now, I just mentioned before, the information that we get from those events and the blockchain data might not be the more human readable. Maybe you want to not only enrich this data and you want to map it with some other data sources. Maybe you actually want to think about, I want to aggregate this. I made an example of we want to collect all transactions from a specific address. Maybe you want to do some calculations. Maybe you want to understand the analytics, from where A and B are going the tokens. So we need to be able to understand on an ongoing basis what's actually happening. So this is one of those questions that I also get asked often. So I put down a sample architecture on how you could build this, where again, we would have our node, because we said this is the gateway into the space of blockchain. We have our node. It can receive all our events and the news blocks and all the information. We can make sense of this information. Maybe we want to already start aggregating, or we want to do some computations, or we just want to map it with this specific hash is actually user ABC because these are our users and we know these. But then we don't want to have the data just live on the machine. Maybe we want to have this data live in a database or in a small data lake somewhere. Like we saw earlier in the 1inch case where this data is actually being put onto S3 and then made available for all those microservices. And a simple way to do this would actually makes it very much plug and play, putting the pieces together. You could use a streaming service like Kinesis, which your application just gets an endpoint where you stream your data against, and then it lands automatically in S3. You can also do some partitioning, all the magic that you need to get your product up and running. So now we have our information living in S3, but we also want to be able to access it, right? We want to make sense of it. So here as an example, a way to actually query information that is stored in S3 is to use a serverless SQL engine in the AWS native way, would be Amazon Athena, that actually allows it to shoot SQL queries against structured data that lives in S3. So it makes it very easy to do ad hoc querying and answer questions and information that you want to that you are searching for. But maybe you want to use your SQL Workbench tool of choice. This is also possible because Athena actually provides an ODBC, JDBC driver where you can just use your tool and connect via the driver onto this information, and then it's all about the tools that you need to get the job done. So here again, I put some information here on the QR code at the bottom. You see some building blocks, so not all of the things you need to think of yourself. There's a lot of content out there with step-by-step guides and code examples and samples applications. But I promised one more thing. It was about learning something, but also accelerating your journey. While this is great, we can see how this works, and there's some examples here. There's one step further we can go in the analytics case. So if you want to make sense of the information that is stored on the Bitcoin and Ethereum case, as AWS actually publishes a public data set, an open data set that is free to use, that has information and pre-populated tables easily for you to query for the Bitcoin and Ethereum blockchains. You actually see here this whole collection of services, all of the solution that is basically that we are running for you to collect this information. You can take this and adapt it on your own. This is open source. When you go onto this GitHub link here, you see all the parts required to get this up and running if you want to do this on your own. If you maybe want to focus on something specific, so for the Ethereum people here, maybe you want to zone in on some ERC20 token specifically and only collect the data. Or you use this framework of collecting this data and write some new consumers for other blockchains. So a lot of the blueprints are already there, and you don't need to start from zero. But again, there's no need for you to run this on your own because we're publishing this data set for free for use. You see here actually the URLs of the buckets. You can go and check it out today. And you see the different kinds of aggregation levels that we have that makes it easier for you to actually find this information. There's one small disclaimer I have to make. This is historical data. So if you're looking into real-time data, there's a way how you can put those two things together. And I don't have the strength to open my bottle right now. There you go. So actually, on the GitHub page, you also find how you can put the real-time case and this historical data case together. So all the steps are outlined there. The data, while we're collecting them during the day, so all of the data is still being collected. It's just that once a day, for this Ethereum case, we actually bunch them together and populate those data tables and put them into optimized data file formats, so you actually then can get more performance out of all those computations. Now, since we have all this data already indexed, so you don't need to do the work, you don't need to spin up an archive node, right? A big machine that usually uses a lot of space, we're talking about 1.5, 2 terabytes of data. wherever Ethereum is right now, it kind of changes over time when they truncate. But it's a lot of data that a lot of storage that you don't need to pay for, but it's not needed because the data is already indexed there for you. And you feel free to use this. You can, again, we had the Athena, the case before, to shoot queries against it. Maybe you want to load it into a data warehouse like Redshift. To do this, you want to do machine learning with SageMaker. So all of those things are possible. Use that data, repivot it, just look at specific addresses so you collect all this kind of information. The data is out there and free to use. Great. So now, how can we get started today? So one of the main things I want you to take away is look at the things that are already out there. You want to build something specific. You don't need to reinvent the wheel. You don't need to build all the things on your own. There are many solutions already out there. I outlined a few, and there's way more out there already. Be it starting with a managed node offering for Ethereum so you can go up and running, or the open data set that we just discussed, where you can use the data, but you can also use the solution that is being used behind the scenes. But also how to do transaction handling and signing. I didn't go into this into detail, but there's a lot of step-by-step guides and architectural guidance and code snippets and sample examples that you can use to get up and running. So really, use those common patterns that are out there. Don't reinvent the wheel. Focus on the things that make your product great. Since we're talking to a startup audience here, you've already made one good choice today, and that is coming to this talk. I hope you learned a lot, but there's also so much more we can help you with. So on the AWS Startup Loft, we are providing a lot of events and talks and further information. Just last week, I gave a talk on Web3 in AWS. That was quite popular, so it was really nice to see all that interest, and we're going to have more of these kind of sessions in the future. But it's not only the technical stuff. We talk about how to build a winning pitch deck and how to talk to VCs, the technical topics, so this whole palette of things that you need to get to be successful with your startup. And on the other side is the AWS Activate program. I encourage you to go and sign up. There are different tiers on how we can support you with credits. And also that gives you access to even more content. The AWS Startup Loft, it's free to sign up. I highly recommend doing that. So now, technology makes innovation possible. But in the end, it's people who build that technology. And while we talked about a lot of different approaches to do this, I hope that you have this feeling that the best time to build is now. So I'm leaving here with saying thank you for listening. There's a lot of things we went over. If you want to go into details on some of those topics, again, I will be available after the talk over there at the lit up letters. And get in contact with us. Here you have our handles, or on LinkedIn, or via email, reach out, and there's much more content we can share with you. Thank you so much for your attention, and enjoy the second half of the day.